This is R.D. Sharma Solution Class 12, Chapter 19. Exercises 19.9. Indefinite integrals we are talking about. Under root e raise x minus 1 dx. So first thing is that we need to get rid of this under root. If you have some denominator, then we'll try to put that denominator and try to get the numerator. But here there is no denominator. For that, we need to get rid of the under root. These are certain tricks which you can follow. So this t is under root ex minus 1, t square will be e raise x minus 1. And when we differentiate this, and since we have to put this e raise x also, it will be t square plus 1. So let's differentiate now. 2t dt by dx will be e raise x. Now e raise x minus 1 whole is t. So what about dx? Because you have to put dx also. So from here, dx will be what? Just take dx on one side and other things on other side. Then we'll formulate the dx. It's t square is e raise x minus 1. So this e raise x will be t square plus 1. We'll put it here. Dx will be equal to 2t dt and divided by what? It's e raise x. E raise x is t square plus 1. So what is the benefit now? Integration will be, this will be t. Under root e raise x minus 1 will be t. And this whole dx will be 2t dt by t square plus 1. Let us write it. 2t dt by t square plus 1. 2 I am taking it in front of the integral sign. This will be t square, denominator will be t square plus 1 and dt will remain like that. So this is t square plus 1 now. So we'll add a 1 and subtract a 1 just to get the two terms which can be integrated easily. So this will be t square plus 1 by t square plus 1 minus 1 by t square plus 1. So this is going to be 1. We are going to deal this 2 later. This is integration of dt minus integration of t square plus 1 dt. So the direct integration is feasible here. Dt will be t. 1 by 1 plus x square is tan inverse x. So it will be tan inverse t plus constant of integration. 2 was there. So let's multiply 2 and t will replace by under root e raise x minus 1. Let's write it. 2 under root e raise x minus 1 minus 2 tan inverse under root e raise x minus 1 plus constant of integration. That's your final answer. So this is how we are going to do this. The main thing is you need to get rid of this under root. For that you have to put t square as under root e square minus 1, e raise x minus 1. And then we will try to replace dx with whatever we get when we do the differentiation. Now this question we have x plus 1 in the denominator. And the denominator we have x square plus 2x plus 1. I'm taking this 2 as 1 plus 1. So x square plus 1, that is 1 square only, plus 2x we have taken 1, so we are just left with 1 only. So what do you get? X square plus 1 square plus 2x, it's x plus 1 whole square. Plus 1 is there. So what do we get? Integration will be integration of 1 by x plus 1, and this x square plus 2x plus 2 has become x plus 1 whole square plus 1. And this will be dx in the numerator. So this t is equal to x plus 1 will take it at, because dt equals to dx when we differentiate it. So this integration will be, this dx will be dt, so dt divided by x plus 1 is t, x plus 1 square is t square plus 1. But still we are lacking. Still we have to do something. So we'll take this t square as a p. So 2t will be equal to dp by dt. So how do we get? Because we have to replace dt by whatever we have on the other side. So dp will be 2t dt, or you can say dt will be dp by 2t. So this dp by 2t will be replaced in place of dt. So integration will be, this dt will become dp by twice of t, dp by twice of t. This t is already there and t square plus 1 is there with us. So what do we get? What is the benefit of taking this t square as p? This is dp and this is 2t square and t square plus 1. I'm just writing it because I just want to show you why this p was taken as t square, because p, wherever t square is there, we'll replace it by p. So this is dp, half will come outside. This is p and this is p plus 1. Now what is the benefit of this? You will ask question. Half dp, just multiply this, p square plus p. Now this p square plus p is kind of a quadratic equation without a constant. So in order to make a perfect square, whatever is in front of p, just make it half, because it is 1, so we make it half, so it will be half. Square, add and subtract, that is just square it. Square, add it and subtract it. So a square plus b square plus 2ab, it's p plus half whole square. The first three terms, p square plus p plus half square, is simply p plus half whole square. The other term is minus half square. So this is half dp, same thing I'm writing here, p plus half whole square minus half whole square. So it's a kind of x square minus a square in the denominator. So integration of this dx by x square minus a square is equal to 1 by a log x minus a by x plus a. That you already know. X is whole p plus half and a is half only. So this is going to be half. So this will come here. Please just worry about the constant, because constant is main thing which can change your result. But log p plus half, because x minus a, so p plus half is x, a is half, so p plus half minus half. In the denominator it will be p plus half minus half plus constant of integration. So this numerator will be p only. Log half gets cancelled, it will be p only. Half plus half is 1. So this is p plus 1 plus constant of integration. Now p was t square. So log t square by t square plus 1. This is log plus constant of integration. What was t square? If you remember, if t is x plus 1, t square will be x plus 1 whole square. So you can just write it here. X plus 1 whole square divided by this x plus 1 whole square plus 1 plus constant of integration. Now you can resolve this, and x plus 1 whole square you can just take 2 in front, because log x to the power y is y log x. So log x plus 1 whole square, you can take this 2 in front that I just told you. This 2 comes in front. So let us write it here. It's 2 only. So 1, 2 initially, then we got another 2. That was done. Now we have another 2 here. So there is a 2. There is separate cancellation, which is already done. Now for this x plus 1 whole square, there is a 2 again in the picture. And in the denominator, x plus 1 whole square plus 1. So x square plus 1 square plus 2x plus 1. That is x square plus 2x plus 2. That is what was originally in the question. This is your final answer. So log x plus 1 divided by x square plus 2x plus 2 in the root. This is your final answer. So this is how we are going to do this. Don't worry about the constant, that is quite known to you. 2 and half will get cancelled. There will be half remaining. That goes to the power inside, and that will form a root. X to the power 5 divided by under root 1 plus x cube. Now x cube equals to t, you will get some x square term. So we can adjust the numerator accordingly. So x to the power 5 can be written as x cube and x square. Power gets added. If you multiply x square and x cube, you will get x to the power 5. So you have x cube and x square in the numerator with a dx. The denominator will be 1 plus x cube. This x cube, this is going to be t. X cube is t. So this dt by dx will be 3x squared. dt by 3 will be equal to x square dx. And this x square dx, we will just replace it by dt by 3. This is dt. 1 by 3 comes here. X cube is t. And 1 plus x cube. It's better to take 1 plus x cube actually. So I'm just changing the approach. I'm not taking x cube as t. I'm taking x cube plus 1 as t. The result will remain same. Only the denominator, rather than having 1 plus t, we can have under root t. Accordingly, we'll change the numerator, because t minus 1 it will be, because numerator will be x cube. That's what we wanted to put. So this will be 1 by 3 in front. Let us separate them out. 1 by 3 will deal later. So t by under root t dt minus integration of dt by under root t. So t raised power 1, t raised power half, this goes up. 1 minus half is half only. So t raised half it will be. This will be t raised half minus t raised minus half. We'll differentiate it in terms of dt now. So t to the power half plus 1, that is 3 by 2. 3 by 2 will be in the denominator. It goes up and it will form 2 by 3. T raised minus half plus 1 will be half only. T raised half. 1 minus half is half. It will be t raised half. Denominator is negative half plus 1. Again half. So 2 goes up. So what was t? X cube plus 1, or 1 plus x cube. So 2 by 3 x cube plus 1 to the power 3 by 2 minus 2. T was 1 plus x cube. So 1 plus x cube to the power half plus constant of integration. Now I told you that 1 by 3 will be dealing later. So 3 will be multiplied. So 2 by 9 and 2 by 3 will be formed and multiplied by c by 3. So that will be constant only. So this is how we are going to approach this question, and this is the way you can solve it. Please remember, x cube equals to t will be, it will add some effort. X cube plus 1 equals to t will be easier. Next one also, 5 minus x square equals to t, you will get x square x term. So you ought to have this x square x cube can be changed into x square into x. 4 I have taken outside, under root 5 minus x square. Now 5 minus x square, this you can take as t, dt by dx will be equal to, 5 will be 0, this will be minus 2x, this whole x dx, just multiply dx here and bring this negative 2 on the denominator. So x dx will be minus dt by 2. This will be 4. Let's take this 4 will deal later. Okay, x square from here will be t 5 minus t. So in place of x square, write 5 minus t. 4 for later. X dx is negative dt by 2. So minus 4 multiplied by this negative 4 will because of this negative dt by 2. So it will be negative 2 minus 4 by 2. 5 minus t under root 5 minus x square is a t. Under root t it will be. Now let's multiply. 5 under root t is t to the power half. So 5 I am taking outside, t raised half. Now multiply t with under root t. So t into t to the power half, t to the power 3 by 2, 3 by 2. This is integrated with respect to dt, and negative 2 will deal later. So what will be the integration? T raised half plus 1, that is 3 by 2. Denominator you have half plus 1, that is 3 by 2. It goes up, it will be 2 by 3. And 3 by 2 plus 1 is 5 by 2. So it will be 2 raised 5 by 2. This 5 by 2 in the denominator goes up, and 2 by 5 it will be. So this is going to be 5. And 2 is, negative 2 is still there in the number negative 2. I told you that I'm going to deal it with later. So negative 20 by 3. What was t? 5 minus x square. So 5 minus x square to the power 3 by 2 minus 2 by 5. So you have to multiply it by negative 2. This will be plus 4 by 5, and in place of t, 5 minus x square to the power 5 by 2. That's constant of integration. Now this is how you are going to go about it. And this question has no catch. Just x cube can be written as x square and x, and rest things are known to you. So this question we have not done, but when after 2 step or 3 step, you'll realize this kind of question we have already done. You'll just see. If you take this root x outside, what are you going to get? Don't worry, just divide root x inside and then formulate what will be the denominator finally. So I'm dividing root x because I have multiplied root x in the denominator. So root x will be there, root x by root x will be 1, x by root x will be what? Multiply numerator, denominator by root x. So root x will give you, this will be x get cancelled. So you have a root x. So this kind of question we have already done. I told you after 2 steps, you will realize this question already done. So 1 plus root x will be taken as t. dt by dx will be what? 1 by twice of root x. So this dx by root x we got. So this dx by root x will be dt by 2. So let us replace it. Dx by root x we will put dt by 2. So this dt goes here, half goes down. 1 plus root x was t. It's simply log t. The final integration will be, because 1 by t, dx by x is log x only. This is 2, not half. Okay, there is a slight change here. Log modulus of t plus constant of integration with 2, and t was 1 plus root x, so just change it. Log in the modulus you have to take t as 1 plus root x plus constant of integration, right? So this is the way we have to go about it. Root x, if you take outside, if you know that, then other things will be quite easier. Please don't forget to put this modulus side. Now in the previous question we have seen that if we change certain things or we reformulate the question, we'll be able to do it. Now what does it mean? 1 plus x to the power 4 to the power 3 by 4. It simply means 4th root of 1 plus x to the power 4 cube, right? So if we take x to the power 4 outside of this one in the root only, 1 plus 1 divided by x to the power 4 will come, cube will remain there. So it will be x to the power 4 into 3, that is x to the power 12. And 1 plus 1 by x to the power 1 plus 1 by x to the power 4 to the power whole 3. Now what is the benefit? Because x square is already there. This x to the power 12, 4th root, when you take 1 by 4 of x to the power 12, it is 12 by 4, that is 3. X cube will come outside. See, 4, and this is cube. So if you replace this, x to the power cube whole 4, and take the 4th root, this 4 will get cancelled. Only x cube will come out from x to the power 12, that you already know. X cube comes out, so this integration will be 1 by x cube. X square was already there, x cube will come out. Let us write it as x cube. In the denominator, what do you get? X raised 4 plus 1 to the power 3 by 4. We have now changed it into 1 plus 1 by x to the power 4 to the power 3/4 root. So it's just 3/4. Now what is the benefit? Now I'm taking this in the numerator. 1 plus 1 by x to the power 4 in the numerator, it's negative 3/4. This x square and x cube, x to the power 5 it will come. And now you realize if you take x raised 5 or 1 by x to the power 4, we can get x to the power 5. That is t equals to 1 plus 1 by x to the power 4, dt by dx will be negative 1 by x to the power 5. That's what is in the denominator, dx by x to the power 5. We have got its negative dt. So when we differentiate this x to the power minus 4, it goes up when. So n x to the power n minus 1. So it will be negative 4 into x to the power 5, negative 5. So x to the power 5 will come in the denominator. So we have a negative 4 also. So what do? We just need dx by x to the power 5 on one side. So dx by x to the power 5 will culminate and will result in negative dt by 4. It will be 1 dx by x to the power 5, which is already there in the simplified form which I just told you. So let's do it here. I have less space, so just bear with me. So let's integrate now. 1 plus 1 by x to the power 4 was taken as t, so it will be taken t raised negative 3/4. dx by x to the power 5 is negative dt by 4. Negative 1/4 I have taken out, dt remains there. Now it's just x to the power n integration. It will be t raised negative 3/4 plus 1 divided by negative 3 plus 4/1. What is 1 minus 3/4? It's 1/4. So 1/4 in the denominator, it goes up because negative 1/4 is already there. This goes up 4/1, so only negative will remain. Other things will vanish or they will be cancel out. What is in the numerator? It's t to the power 1/4 plus constant of integration. So you have negative t raised 1/4. What was t? 1 plus 1 by x to the power 4 to the power 1/4. That is the 4th root plus constant of integration. That's your final result. So this is the way you have to go about. All sign and all symbols have to be utilized. Don't just do the way I told you. It has to be written like this. This is the very important part which you need to actually consider. Now sine raised 5x and cos raised 4x. If you take cos x equals to t, you will get a sine. And sine is in the odd power. So we are getting to the solution. Because there is no that much of simplification as we did in the previous few questions. So this sine raised of 4x into sine x is eventually sine raised 5x. Cos raised 4x, it will be cos raised 4x only. So if you put cos x equals to t, you will get sin x dx eventually. So what to do with this sine 4x? Sin square x plus cos square x equals to 1. Sin square will be equal to 1 minus cos square. So power 4 is 1 minus cos square whole square. So this sin raised 4x will be 1 minus cos square x, which is eventually equal to cos square x, sin square x, and that is whole square of that thing. So it's square. So sin x dx remains there, cos raised 4x in the denominator. Now if you want to just change them, that is, you can separate them out, that also you can do. But now I would advise you to just put this cos x equals to t right now. So dt by dx will be equal to, what is the differentiation? Cos x will give you negative sin x. So negative dt is sin x dx. So this is your sin x dx. It is negative dt. It will be integration of 1 minus cos square x will be 1 minus t square whole square. Sin x dx is negative dt. So let's just put dt and negative outside. And we have cos raised 4x. So t raised 4. So now let's open it. We will open this and then formulate certain terms which can be differentiated easily. So a square plus b square minus 2ab, 1 square plus t square whole square, that is t raised 4 minus 2 into t square. The denominator you have t raised 4, here also t raised 4, same thing. So t raised minus 4, this will be 1, and when it goes up, 2 minus 4 is negative 2. So t square, t raised minus 2 it will be. So we'll integrate it separately now. It will be very easy for you now. T raised minus 4 is t raised minus 4 plus 1 divided by negative 4 plus 1. This will be simply t. This is going to be minus 2. T raised minus 2 plus 1 divided by negative 2 plus 1 plus constant of integration. Now this is t raised negative 3 divided by negative 3 plus this will be t negative 2 and this will be negative 1. So I'm just changing the sign. This will be t raised minus 1 and that simply means 1 by t. So 2 by t plus constant of integration. So minus was already there in the beginning. If you remember, I told you negative will use. Just multiply everything with a negative. So t will be cos x. The final replacement will be 1 by cos x whole cube with a 3 there minus t was cos x minus 2 by cos x plus constant of integration. That's your final result. So this is the way you can do it. So I have taken cos x equals to t way earlier. So these are 72 questions we have done. I hope you have a better idea now. So thank you so much. Have a good one. This is all about this exercise.